Hello, my name is Shabsina and today I will be teaching you guys the DS stack. So this is one of the most important topic of data structure. So let's begin. So let me first introduce about the stack. A stack is a linear data structure that follows the LIFO, last in first out principle. Stack has one end whereas the queue has two ends. It contains only one pointer, top pointer pointing to the topmost element of the stack. Whenever an element is added in the stack, we can say that it is added on the top of the stack and the element can be deleted only from the stack. In other words, a stack can be defined as a container in which insertion and deletion can be done from one end, known as the top of the stack. So this was the introduction of the stack. So let's go to the some key points related to stack. It is called a stack because it behaves like a real world stack, piles of books, etc. A stack is an abstract data type with a predefined capacity, which means that it can store the elements of a limited size. It is a data structure that follows some order to insert and delete the elements, and that order can be LIFO or FILO. Now let's come to the working of a stack. Stack works on the LIFO pattern. As we can observe in the below figure, there are 5 memory blocks in the stack. Therefore, the size of the stack is 5. Suppose we want to store the elements in a stack, and let's assume their stack is empty. We have taken the stack of size 5 as shown below, in which we are pushing the elements one by one until the stack becomes full. So as you can see in the diagram, since our stack is full as the size of the stack is 5, in the above cases we can observe that it goes from the top to bottom when we were entering the new element in the stack. The stack gets filled up from the bottom to the top. So as you can see in the diagram, that it gets filled up from the bottom to the top. So when we perform the delete operation on the stack, there is only one way for entry and exit, as the other end is closed. It follows the LIFO pattern, which means that the value entered first will be removed last. In the above case, the value 5 is entered first, so it will be removed only after the deletion of all the other elements. So now the standard stack operations. So the following are some common operations implemented on the stack. First is push operation. So when we insert an element in a stack, then the operation is known as a push. If the stack is full, then the overflow condition occurs. Then comes the pop operation. When we delete an element from the stack, the operation is known as a pop. If the stack is empty, means that no element exists in the stack. This state is known as an underflow state. Then the is empty operation. So what does it do? It determines whether the stack is empty or not. Then the full operation. So obviously determines whether the stack is full or not. Then the peak operation. It returns the element at the given position. Then the count operation. It returns the total number of elements available in a stack. Then the change operation. It changes the element at the given position. And finally, the display operation. It prints all the elements available in the stack. So now let's discuss about the push operation. So the steps involved in the push operation is given below. Below inserting an element in a stack, we check whether the stack is full or not. If we try to insert the element in a stack and the stack is full, then the overflow condition occurs. When we initialize a stack, we set the value as top as -1 to check whether the stack is empty. When the new element is pushed in a stack, first the value of the top gets incremented, that is top equal to top plus 1, and the element will be placed at the new position of the top. The elements will be inserted until we reach the max size of the stack. So now the pop operation. The steps involved in the pop operation are: before deleting the element from the stack, we check whether the stack is empty. If we try to delete the element from the empty stack, then the underflow condition occurs. If the stack is not empty, we first access the element which is pointed by the top. Once the top operation is performed, the top is decremented by 1, that is top equals to top minus 1. Then the application of stack. So first is balancing of symbols. So stack is used for balancing a symbol. For example, we have the following program: integer main, cout, hello, and Java T point. So we know that each program has an opening and closing braces. So when the opening braces come, we push the braces in a stack, and when the closing braces appear, we pop the opening braces from the stack. Therefore, the net value comes out to be 0. If any symbol is left in the stack, it means that some syntax occurs in a program. Then the string reversal. So what is string reversal? So let me explain in a brief way. We can say that stack is also used for reversing a string, right? So for example, if we want to reverse a Java T point string, so we can achieve this with the help of a stack. First, we push all the characters of the string in a stack until we reach the null character. After pushing all the characters, we start taking out the character one by one until we reach the bottom of the stack. The second is undo redo. It can also be used for performing the undo redo operations. For example, we have an editor in which we write A, then B, and then C. Therefore, the text written in an editor is ABC. So there are 3 steps: A, AB, and ABC, which is stored in a stack. There would be 2 stacks, in which one stack shows undo state and the other shows redo state. If we want to perform undo operation and want to achieve AB state, then we implement pop operation. Then comes the recursion. The recursion means that the function is calling itself again. To maintain the previous steps, the compiler creates a system stack in which all the previous records of the function are maintained. So after that comes the DFS. So this search is implemented on a graph, and graph uses the stack data structure. In the backtracking, suppose we have to create a path to solve a maze problem. If we are moving in a particular path and we realize that we come on the wrong way, in order to come at the beginning of the path to create a new path, we have to use the stack data structure. Then comes the expression conversion. So stack can also be used for expression conversion. This is one of the most important applications of stack. The list of the expression conversion is given below. First is infix to prefix, second infix to postfix, third is the prefix to infix, fourth is prefix to postfix, and final is postfix to infix. And finally comes the memory management. So the stack manages the memory, as we all know. So the memory is assigned in the contiguous memory blocks. So the memory is known as stack memory, as all the variables are assigned in a function called stack memory. The memory size assigned to the program is known to the compiler. When the function is created, all its variables are assigned in the stack memory. When the function completed its execution, all the variables assigned in the stack are released. So that's all from my side today. In the next lecture, we will learn about the DSQ and its types. So till then, bye.